And then we stop basically at this example. So what we will do today, inshallah, is we continue with the concept of independence, give more examples about it, and then we talk about combined experiments. We have more than an experiment, and then we start the counting principles. How to count the outcomes of an experiment. Okay, so we stopped at this example, which basically have a deck of cards, 52 cards, as you know, and we define several events. Event A is select the king. Event B is select a jack or a queen. Select jack or wallet. Event C is basically the heart, selecting the heart. And we said, okay, let's now examine the probabilities, the different probabilities. First of all, what is the probability of A? All over 52. Why? Because we have 4 things out of 52 girls. What about the probability of B? 8. Then عندنا 4 queens and 4 jacks. What about the probability of C? 13 over 52, which is 1/4, right? 1 over. Okay. And so on. Now, what is the probability of A intersect B? A intersect B. And we select the king and jack of B at the same time. So, what is the probability of A intersect B? 0. Huh? So, probability of A intersect B is clearly 0. What about A intersect C?
1 over 50.
A intersect C is basically selecting a king that is hard. And then our back is, one of them is hard. So basically it's 1 over 52. Okay. And selecting now A, B, and C. Yes. B and C. Can we select jack or queen and heart at the same time? Can basically, and it is 2 over 52. Now let's check whether A, B are independent or not. And then how do you do that? Logic, concept, physical meaning, or the math. Okay, so looking at the math, even if you don't know probability, you can just find it. What is the probability? ايش الماث يقول? In order to be independent, what do you need to have? The probability of A intersect B equals. Guys, you just check that. Probability of A intersect B is 0. What about the probability of A? Come. 4 over 52. Probability of B, 8 over 52. Because multiplying them does give 0. So basically, they are not independent. Now, logically, so mathematically, they are not independent. Mathematically. However, logically, as we mentioned, selecting a king excludes selecting jack or queen. They cannot happen at the same time. And because of that, they are mutually exclusive. And hence, they are not independent. Now, A and C, are they independent or not? Mathematically, I'm sure. A intersect C is 1 over 52, while A is 4 over 52, C is 13 over 52. Multiplying 13 over 52 by 4 over 52 will give you 1 over 52, which is checked. From the practical point of view. From the concept point of view, as we mentioned before, selecting a king doesn't change the probability that whether it's a half or not. Two people king, and back kings, one of them is half, right? So still, the probability of selecting the half, given that it's a king, it's still 1 over 4, which is the same as selecting a half to start with. Okay? So selecting being a king doesn't change the probability of having a half. Now B and C, selecting a jack or a queen, selecting a half. Mathematically, you can check that this is valid. So it means that they are independent. And as mentioned before, you can basically select the jack or queen without affecting whether it's a half. And vice versa. If it's a half, can be still jack or queen. And the probability of Jack or Queen given hat doesn't change without given hat or not. واضح يا شباب الفكرة؟ Any question about independence and how to check for it? Logical point of view and mathematical point of view. Any question? Here? Now, if we have multiple events, not only two events. So I think I will discuss the two events, A and B being independent. And we said that in order for A and B to be independent, the probability of A intersect B should be equal to probability of A multiplied by probability of B. This is two events independent. What about multiple events? Three events, for example. A1, A2, and A3. If they are to be said, if we need to say that they are independent, then the intersection between A1 and A2, the probability of the intersection should be equal to the product of the individual A1 and A2. The second intersection, A2 and A3, the probability of A2 intersect A3 equals the product of A2 and A3, and also the third intersection, A1 and A2. So there should be, first of all, this is called pairwise independent. So checking every two of them, they are independent. And not only that, you need to verify a second condition, which is the probability of A1 intersect A2, intersect A3 should be equal to the product of the individual. So first of all, they must be pairwise. Second, they need to satisfy equal independence. If you have four now, if you have four events, and you would like to check the probabilities, first of all, they need to be pairwise. So A1, A2, A3, A1 with A2, A1 with A3, A1 with A4, and so on. And then كل ثلاثة. بعدين أضع and so on. Okay? Now an example. We have here choosing a number, and this is the sample space. 1, 2, 3, 4. A1 is 1 and 2, A2 is 2 and 3, A3 is 1 and 3. I gave you these events from the sample space. And the sample space is equally likely. So now the probability of A1, first of all, checking the probability of A1. What is probability of A1? 2 over 4, right? Probability of A2. Probability of A3. 2 over 4. Okay. What about probability of A intersect A1 intersect A2? A1 intersect A2. A1 intersect A2 كم ايش الكومن elements بينهم؟ Only the two, right? So basically we have 1 over 4. Is it equal to the product? Half multiplied by half? Okay, so basically it's equal to out of A1 multiplied by half. So this is the first two, the first pair, A1 or A2 are independent. What about, check for me A2 and A3. Very quickly. Check A2 and A3, whether they are independent or not. One common element, so the probability, the intersection will be again 1/4, the probability of the intersection, which is equal to the product. What about A1 and A3? Similar, right? Everybody's following? Now, what about the three of them? Now, what is the intersection of the three of them? A1 and A2, you have 2 as common factor. A1 intersect A2 is 2. What about A1 intersect A2 intersect A3? 5. So the probability of the intersection between the three is equal to 10. It's equal to probability of 5, which is 0, right? Is it equal to the product of the three probabilities? Half multiplied by half multiplied by half. Okay. So this is a second example of independence. Now, If A1, A2, A3 are independent, then A1 should be independent with or from the intersection of the two or the union of the two, or any combination. Basically, one of them should be independent of any combination of the union and intersection of the other. زي ما اتكلمنا قبل كده, when you have two events, A and B, we said that A is independent with B, means that A is independent with A complement. Accident, right? Similarly here, A1 is independent with A2 from A2 and A3. It is independent from their intersection, union, and so on. لا القاعدة تقول they are independent if and only if هذه تعرفوها if and only if they are pairwise independent and this condition sets. يعني the first one pairwise independent and the second condition should be. في المثال طلعوا pairwise independent كل واحد independent من الثاني. However, they are not ثلاثة they are not independent. Any questions about? Okay. We said that before. If A is independent from A2, then A1 is independent from A2. And we verified this and even we proved it. Now, in general, if two events or three events or four or five or whatever are independent, then the way we write the probability, which is the intersection, probability of A intersect B, this changes into, intersection changes into product of probabilities. أول ما تشوف independence, you can just dismantle the probability of كذا into the product of the individual because of the independence. So whenever we see probability of A1 intersect A2, intersect A3, then this is equal to the probability of A1 and multiplied by the probability of the other two. And if A2 and A3 are independent, then it's equal to the product of probability of A1 multiplied by the product of the other two. So the intersection is what? Now when we say event intersecting event, in terms of our understanding, what do you mean? معناها ايش الوصله يعني ايش الكلمه اللي بنسويها and yeah, so basically when we say دائما يذكروها when we say probability of A intersect B, this means that we are talking about probability of A and B happening. So intersect means and means intersect. دائما مرات تلاقيها في المسائل الكلامية or you after you finish this you find it in many places in your life when you say and means intersect. زي ما قلنا في الإجابة حق 52 ذكر we say that quality of heart and skin. So basically the card that you will pull, it is heart and skin. This translates into intersection between the heart and skin. Okay. Okay. Now, let's talk about this example. The decal with and without replacement. Again, we go back to the deck of cards. The union is all. Yeah, that's a good question. I can't work to see. When we say probability of A union B, go back to the heart and the king. When we say probability of king union heart, ايش معناها؟ معناها I pick a card, it could be either king or heart. So union means or. Probability of A or B. So union and or are interchangeable. Mathematically, we write it as union using the set theory. Like when we talk in English, we say what? يعني مثلا احنا السؤال قبل شوي كتبنا B equals الايفنت B was Jack or Queen. معناها ايش؟ واحد منهم يصير. So we combine, we add it, and because of that it's union Jack or Queen. And he tells لا هنا ما في طبعا the probability of union independence has nothing to do with it. The probability of union when you have disjoint or mutually exclusive, this is equal to the addition, the summation of the probability of A and plus the probability of B. If they are disjoint. If they are not, minus the intersection. So here we don't have anything about independence. Okay, so this is a very common issue. Many students continue that when you continue the course state, they don't distinguish between and or. And when do we use intersection? When do we use union? We need to be clear about it. From the physical point of view and from the mathematical point of view. طيب الآن let's have an example about the experiment with replacement or without replacement. So here we are saying drawing 4 aces. So we have here the same 52 deck of cards, and we are drawing 4 aces. كل مرة نdraw المرة الأولى أول شيء خلينا نتكلم عن without replacement, and then we'll talk about أول شيء with replacement. So let's talk about الكيس الأولى with replacement. With replacement means what? I select the card, أشوف is it ace or not. Ace اللي هو رقم 1. And then I replace it. And then I select another card. Random. I did أشوف ace or not. And then I put it back. ايش probability that I select 4 aces in a row? 4 over 52 هذا أول ace. طيب الآن رجعت مرة ثانية. What is the probability that I select? It's 4 over 52 multiplied by. كل مرة أسحب ايش الايفنتس هذه؟ independent ولا لها علاقة ببعض؟ تمام. When I select the first card, أشوفه وأرجعه. Select the second card. الآن selecting the second card, is it independent from the first card or not? ليش؟ لا الكاردز موجودة. أنا شفت مرة ثانية وبعدين شلت واحد ثاني. So basically, the withdrawing of the card because of the replacement, كل مرة أرجع الكارد مكانه means that the deck is the same. Is السحبة الثانية ما لها علاقة بالأولى، السحبة الثالثة ما لها علاقة بالأولى والثانية، السحبة الرابعة ما لها علاقة بالأول ثلاثة. And because of that, when we say with replacement, with replacement, the probability of A1 intersect probability, or sorry, A2 intersect A3 intersect A4, which is basically we have 4 aces in a row equals the probability of A1 multiplied by the probability of A2 multiplied by the probability of A3 multiplied by the probability of A4. Agree? Which is 4 over 52 to the power 4. No matter علاقة بعد. كل مرة I'm just repeating the experiment again, and it's the same sample space. However, if I say أول شيء without replacement, كل مرة أسحب وأرجع الاكسبيرمنت ترجع كأنها مثل الأول، ما تغير شيء. تفضل.
هذه البروبابيلتي هنا واضح 4 4
إي واضح. أوكي. طبعا ورا يعني 4 aces in 4 rows مش 4 aces in 10 rows. أنا أسحب 4 مرات جالس أسأل إيش البروبابيلتي إن يطلع لي 4 aces ace في كل واحدة. I'm not saying 4 من 6 4 من 10. It's a different problem. تمام. هنا the experiment we are drawing 4 times and we are asking what is the probability of having 4 aces in the 4 times. This is different from another experiment that I draw 10 times and ask what is the probability of getting 4 out of the 10. So now, without replacement means that what? You get the card and you take it away. The next draw will be from the deck that is missing the card that you already selected. In this case, this is done. Without replacement, the probability of A1 intersect A2, which is S in the first draw, S in the second draw, S in the third draw, and S in the fourth draw. كل واحدة تعتمد على what you have selected before, right ولا لا؟ Because خلينا نتكلم على السحبة الأولى. What is the point of selecting one S؟ صح؟ طيب الآن أنا أخذت الكارت اللي شفته كده أنت ما تعرف شنو وأنا حطيت عليه. الآن I asked what is the point of selecting another case? Second one. 3 over 50. How do you know? I didn't give you the card. How do you know that I selected a 50? How do you know that there are still 3 or 4? ما تعرف. أنا شفته وحطيته أنت ما تعرف. So in this case, the probability of النتيجة حق السحبة الثانية تعتمد على نتيجة حق السحبة. والنتيجة حق السحبة الثالثة تعتمد على نتيجة حق السحبة الثانية والأولى وهكذا. And we write it this way: the probability of A1 intersect A2 intersect A3 intersect A4 will be equal to أول واحدة ما تعتمد على شيء, which is the probability of A1 multiplied by the probability. This is come 4 over 52 multiplied by the probability of selecting an ace, given that I selected an ace. Because I'm saying what is the probability of الأربعة كلهم aces. So probability of ace in the first round multiplied by the probability of ace in the second round, given that I selected ace. Because I'm making intersection, I'm saying n. Okay? هذه عبارة عن كم يا شباب؟ 3 over 51. 5 دائما تطلع عندي. طيب سؤال أي سؤال على هذه؟ Given that I selected ace in the first place in the first draw, كم بقي aces في الشدة؟ 3 وكم بقي total؟ 51. Okay, so it's 3 على 51 multiplied by the probability of selecting an ace in the third, given that I selected 2 aces before. Then I'm saying here I'm interested in the probability of having 4 aces. Okay? So what is this? باقي 2 aces divided by 50 total cards. Multiplied by the probability of selecting a 4th ace in the 4th draw, given that I selected 3 في أول 3. كم هذه؟ باقي كارت واحد على 49. Okay? And if you calculate this, it will be like very small number. الناس اللي يدخلوا في أعوذ بالله القمار والأشياء هذه, this is the probability that you get this, you get for the house, which is extremely low. And because of that problem, you can't anything. Okay, so the clear is well. But here I'm not teaching this. This is an example that is easy to illustrate. But it doesn't suggest that. برضه الحكمة إنك تعرف إنك extremely low probability إذا حصلت معك مرة في الحياة والنظر. طيب يعني تخيل من كل مليون سحبة you get it free. This is what this. هل معناها إيش؟ معناها من كل مليون 10 to minus 6. معناها من كل مليون محاولة you get it only 3 times. طبعا. ما بيأثر على القانون هنا. Why are we illustrating this? Is this an independent? Are these without replacement? Are these independent? A1, A2, A3, A4 are they independent? No. عشان كده you cannot just multiply. هنا with replacement لما كانت تسحب وتوجه كان independent لأنه النتيجة في السحبة الأولى ما تأثر على نتيجة السحبة الثانية. This is the definition of independence. بينما هنا نتيجة السحبة الأولى تأثر على نتيجة السحبة الثانية، تأثر على نتيجة السحبة الثالثة والرابعة. And because of that they are not independent. So here they are not independent. So you cannot just use the rule that we gave you. Because of without the كل مرة تسحب وتطلع برا ما ترجع مكانها. كل مرة sample space ايش قلنا احنا when you do this sample space changes, and because of that you end up with another set of probabilities. So what we pick here is difference. This is an example of 4 independent events. This is an example of 4 dependent events. معتمدين على بعض. Any question? طبعا.
هذا واحنا نعرف ان اللي شفناه نعرف شيء ولا ما نعرف.
This is يعني هنا الان السؤال بعد ما خلصنا الاكسبيرمنت. انت الان سحبت 4 كل ما تسحب فقابل السقف لما جاء. انا اسالك بعد ما خلصت سحب ال4 كم probability انك تاخذ 4 اكسس. This is basically the question. شباب اي سؤال؟ Any question? Then let's move. So as you can see, until now we have discussed many ideas in sample space, in access to quality, and so on. Very probably they look very similar to you. Maybe كلهم مرت عليهم لو كده في high school or elementary school. However, maybe the analysis and the depth here is a little bit different. So you need to pay attention. Don't assume that you know this. لما تروح تمر على أسئلة الهومورك أسئلة الكتاب تلاقي فيه تركز وفيه أشياء في تفاصيل ما حطها في المدرسة. So don't depend on what you know. Now let's talk about combined experiments. احنا تكلمنا كثير قبل كده while we gave examples and so on على combined experiments لكن we did not define in an official way. يعني قبل شوي الكلام اللي when we draw مثلا 2 cars, this is considered to be a combined experiment because you are doing 2 experiments in one experiment. You are drawing one and then drawing another. So combined experiments is basically are experiments made of sub-experiments. يعني مثلا you are measuring the weather. The weather is not only temperature. The weather بعض أشياء يوجد أشياء تأثر على weather related مثلا the wind speed, the humidity and so on. Right? So basically, in order to be able to define the weather in a better way, you need to define more than one parameter. You need to do more than one measurement. This is called, now when you combine these measurements together, it gives you what we call a combined experiment. خلينا نقول مثلا you measure the weather. Let's say that the weather is defined using 2 parameters. The temperature والhumidity. مثلا في الشرقية humidity is a big issue. Okay? So the temperature ranges من مثلا من 0 إلى 50. ما عمره يمكن نوصل لا ماينس. Humidity ranges from 0 to 100%, right? Now, so basically the sample space here, S1 could be something between 0 and 0 مثلا. بينما السامبل space S2 here is مثلا from 0 to 100. Okay. Now, if I ask you, what is the probability that I get a temperature of 20, exactly 20? كم نحن قلنا probability هنا؟ 0. Like it's possible, I think, right? However, getting a specific number has a probability of 0 because it's 1 out of uncountably infinite set. Similarly here. However, if I ask what is the probability of A, which is an event مثلا خلينا نقول from 20 to 25. It has we're not suggesting it's uniform. لكن it has certain probability. ما تعتمد على الوتر. يعني مثلا probability حقت هذه في الشرقية في نوفمبر is different than probability of A في الصيف صح ولا لا؟ Because في الصيف هذه تقريبا مستحيلة بينما في الشتاء this is highly probable. So we are not suggesting that this is equally likely across the all numbers. بينما مثلا B, we can define here A, we can define B here to be another event, which is خلينا نقول nice humidity من 20 إلى 40. This is another event. However, here we are only looking at the temperature regardless of the humidity. And here we are looking at the humidity regardless of the temperature. Now we can combine them together in a super experiment, أو إذا هذول كل واحدة منهم sub experiment. This would be the combined experiment. How do we define the combined experiment? If we have two independent experiments, S with sample space S1 and probability distribution P1 with n elements. So this is experiment number 1. And we have experiment number 2 with sample space S2 and P2 as the distribution or the probabilities with m elements. Then we can form a combined experiment with S and P with how many elements? N multiplied by m. This is the total number of elements in S, the combined sample space. Where the combined sample space will look like the Cartesian product of the two sample spaces. Basically, you fetch the Cartesian product, you combine them using ordered pairs. Okay? For example, S1 belongs to S, capital S1, S2 belongs to capital S2. And the elements in S will have an ordered pair S1 and S2, where S1 belongs to the first sample space, S2 belongs to the second sample space. واضح الفكرة؟ ايش هو؟ ordered pairs. نعطي أمثلة. مثلا خلينا نقول experiment 1 tossing a coin. Experiment 2 rolling a die. هذا الإكزامبل أسهل إكزامبل. Now I am interested in combining them in one experiment, tossing a coin and rolling a die. وبشوف ايش الoutcomes. I register the head or tail and I register the number that comes out of the. What is the new sample space? The combined sample space look like? It looks like ordered pairs like this: tail and 1, tail and 2, tail and 3, and so on, and then head and 1, head and 2, up to head and 6. What is the total number of elements in S, the combined one? It's 2 multiplied by 6, because it's possible to have head and any one of them, and possible to have tail and any one of them. So it's basically 2 multiplied by 6. This is the total number. The combined مثلا humidity, temperature humidity. The temperature, you can draw it as a line. So this is the temperature today. The humidity, you can draw it over the line. However, the temperature humidity, it needs a map. So there are two-dimensional map to draw it, right? Two-dimensional graph. To tell me where are we? Very hot, very humid, or very hot, no humidity, حصلت في الصيف لما كان غبار وكذا, or medium humidity, very cold, or and so on and so forth. So basically, in order to define the weather in terms of these two, you need a two-dimensional plane. بينما هنا في temperature only you needed a line, في humidity only you needed a line. Here you needed a two-dimensional plane. Every point of this is an ordered pair. Here, هذه النقطة عبارة عن pH, temperature humidity, certain temperature, certain humidity. واضح الفكرة يا شباب؟ طبعا you can have two different experiments like here, or you can repeat the same experiment 2 times, 3 times. This اللي قبل شوي اتكلم عنها. Drawing four cards from a 52 card deck. So repeating n times, flipping a coin n times, مثلا rolling a die 3 times. These are all combined experiments. يعني مثلا flipping a coin n times, flipping a coin 4 times. Nice one. How many outcomes can we have? Flipping coin 4 times. Yeah. How many outcomes? How many outcomes? 16, right? it's 2 multiplied by 2 multiplied by 2 multiplied by 2. So basically it's equal to 2 multiplied by 2 multiplied by 2 multiplied by 2, which is 2 to the power 4, which is 16 in total. Why? Because you can have head, and all the combinations in between. Okay, so every ordered pair will be of how many items? 4. So basically S here will look like head, 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 and so on, until you get tail, 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 tail. Okay. طبعا. In the flipping a coin 4 times, this is one outcome. انت when you flip a coin 4 times ايش تتوقع تشوف؟ 4 اشياء صح؟ 4 وجوه. ممكن كلهم يكونوا head, ممكن كلهم يكونوا tail, ممكن combination of both. So this new experiment, which is flipping 4 times, is composed of flipping the first, flipping the second, flipping the third, flipping the fourth. Combining them will give you a sample space that has 16 different outcomes. كل outcome عبارة عن ordered pair of 4 elements. Element الأول the outcome of the first experiment. Element الثاني the outcome of the second experiment. Element الثالث the outcome of the third experiment, the fourth experiment. نفس الشيء هنا. head and coin and drawing a die. أول element is related to outcome from experiment. كم؟ 1. بينما الثانية experiment 2. أسئلة. Any question? Now let's talk about how can we find the probability of different events. Yeah, I forgot to mention one point here. Now, events in combined experiments. Suppose that I have event A defined on the first experiment and event B defined in the second experiment. Event A could be, in this example, head. Event B could be, in this example, 5. So what is event C? Event C will be the Cartesian product of A with B, which is the order pair. يعني مثلا here A خلينا نقول A is head. B is 2 and 5. So what is C? Yeah, write for me C. Just think about it and write down. What is C? What is C? Which is the product of A and B, or the equivalent event in the combined experiment. Ashra, what is C? H and 2 and what else? H and 5. So the events and the combined experiment should be ordered pairs. Okay. Remember, if it's one experiment, it's just an outcome. Here, it's a set of outcomes. 2 outcomes. Either here or outcomes. For example, here. لا انت الان الاكسبيرمنت الاولى is tossing a coin. الاكسبيرمنت الثانيه is rolling a die. ما تقدر تطلع لك 2 في الاكسبيرمنت الاولى. الاكسبيرمنت الاولى is not about rolling a die. It's about tossing a coin. واضح؟ نعم؟
هذا مكتب الترتيب.
ما ينفع يطلع لك يعني 2 and H. Is it a valid outcome on this? Is it a valid outcome? ما ينفع يطلع لك في الكوين 2 وفي ال so this is not a valid outcome. عشان كده نقول order. طيب So now let's try to find out ways to calculate events on combined experiments. So here we have 3 independent experiments. Sample space S1, S2, S3. These are the event spaces, and these are the probabilities. So the probability of A intersect or Cartesian product with A2, A3 is the product of the probabilities. Okay, why is that? Because the experiments are usually assumed to be random. So in this case, the probability of A1, or the probability of A1 with A and A2 and A3 equals the probability of A1 multiplied by the probability of A2 multiplied by the probability of A3. And this is because experiments are assumed to start with. So now there are the counting of results. When we talk about multiple experiments, مثلا we're rolling the die n times. You cannot really use the simple counting, basically counting methods. Simple counting methods ايش؟ زي ما قلنا قبل شوي اللي هي putting all these هنا طلع لك 16 ممكن يطلع لك 100 ممكن يطلع لك 1000 صح؟ So basically you cannot just keep listing the outcomes. There are smarter ways than listing the outcomes and counting. Listing the outcomes work when you have small sample spaces or small number of experiments. And if I'm repeating this 2 times, 5 times, 10 times, you can still list. However, if I talk about hundreds and thousands and so on, this starts to be boring and damaging. And because of that, there are what we call counting methods, counting principles. الcounting هنا نبدأ الcounting. Counting methods. Counting methods. The very simple or the very basic counting methods are the permutations and the combinations. What are these? Permutations, ask yourself the following question. If I have n students and I would like to select out of it, okay? If I have n students and I would like to select out of them, 4 students, I would like to select 2 out of 4 students. ايش رايكم؟ How many ways I can select 2 out of 4 students? 2 out of 3 خلينا نبدا الشيء اللي كله الادويه 2 ها 2 out of 3 كم مره تختار 2 out of 3 2 بس؟ ليش محمد عبد الله صح ولا لا؟ So basically figures. طيب الان this is selecting students 2 out of 3. Does it matter the order؟ محمد أول ولا عبد الله أول؟ Order is not important. أنا أبغى أسوي فريق من مثلا سينا أودي 2 out of 3. So basically I select either محمد عبد الله أو محمد فهد أو فهد عبد الله. ما تفرق فهد قبل عبد الله ولا عبد الله قبل فهد. Doesn't matter. So in this case order is not important. This is called combinations. And the way طبعا 2 من 3 سهل عندنا محمد فهد عبد الله محمد فهد عبد الله and we can see 3 ways to do it. لكن إذا أسألك أقول لك من 50 how many times you can select من 50 طالب أو 27 طالب how many times we can select 4 students. Can you do it the same way؟ عبد الله وفهد في السلايد ممكن تدرس يومين تسوي فيها وما تطلع. And because of that, we need these counting principles. So the combination gives you the answer to this when order is not important. ما تفرق محمد قبل ولا عبد الله قبل. In this case, n هذه نسميها n choose k is choose r. So out of n, how many times I can choose r? students. هذه نقول عنها and this is the way we read it. and choose this is the way we read it. هذه موجودة في كل الكتب. and choose means what? Means the number of times, number of possible ways to select R out of them and R out of them. Students are Asian. Okay, and this is given by either n choose R or نسميها كده. The combination R among n or combination of R from n. وهذه عبارة عن ايش؟ معروفة الايكويشن حقتها. n factorial تعرف n factorial n multiplied by n minus 1 multiplied by n minus 2 إلى 1 divided by R factorial multiplied by n minus R factorial. And this is in many of the calculators already there for now. However, we need to understand how is it done. Now this is if order is not important. But what about if order important? خلينا ناخذ المثال هذا. Here I'm selecting 3 out of 5. Selecting 3 out of 5. What is the answer? It's 5 factorial. So it's 5, choose 3. Huh? 5 factorial divided by 10. 2 factorial divided by 3 factorial. 3 factorial 5 factorial ايش الفرق بينهم؟ 4 multiplied by 5. والباقي 3 factorial cancel. So basically we have 20 divided by 2. So it's 10 times. So there are 10 times to choose 3 out of 5 students. واضحة؟ هذه هي. عبارة عن A, B, C. إذا عندي أنا A, B, C, D, and E, then these are the different 10 combinations. A, B, C, A, B, D, A, B, E, A, C, D, and so on. شيكوا عليها كلها مختلفة. 10 total. كم؟ 10. Now here order is not important. أنا بس أسوي فريق من 3 أشخاص من 5. However, if order is important, what is the order important? order أنا ما أبغى أسوي فريق. أنا برتب الطلاب من الأحسن إلى الأسوأ أو من الأقوى إلى الأقصى. فأنا أبغى أجيب 3 من 5 وأصفهم في طابور من أقوى واحد إلى أقوى واحد. مثلا in this case order matters. So when order matters, when order is important, in this case شوفوا كم مرة you can order A, B, C. كم مرة؟ A, B, C, B, C, A, C, A, B, C, B, A, B, A, C, and A, C. كم مرة؟ 5 ولا 6؟ عبارة عن ايش؟ عبارة عن 3 فاكتوريال. So the number of times this is 3 factors. So for every item of the 10, every 3 students out of 5, I can order every item 3 times. Sorry, 3 factorial times, which is 6. And in this case, إذا أنا أبغى أرتب الطلاب هذول الثلاثة اللي اخترتهم من 5، إذا أبغى أرتبهم، look at how many combinations we have. كم صار العدد؟ 60. ما عاد 10 بس. ليش؟ Because it's not 5 to the 3. It's 5 to the 3 multiplied by 3 factorial. So basically يصير هنا n factorial divided by n minus r factorial. شلنا ال r factorial ضربناه. Okay, so it's equal to this multiplied by هذه عبارة عن n choose r multiplied by r factorial. Multiplied by. واضحة الفكرة؟ هذه ترى again, you need to understand the concept here. What does order important? What does order not important? Again, here we only choose 3 out of 5 without order. Here we order. In other problems, you will find that there's no replacement. No replacement. So basically, in this with these two such elements, usually no replacement is done. So you pick a curve and you replace it. If you have with replacement, then it becomes لكن هنا it becomes n to the power r. If we allow replacement. Okay. طيب. واضح يا شباب؟ Any question? So next time إن شاء الله we'll. Did you send me the list? طيب send it please now. زميلكم اللي طلع كده نستأذن مني قبل. طيب send me your list. I think we need to. Next time inshallah we'll continue with examples about these combinations. Thank you very much. We need to start solving the first homework because we need to plan for a quiz probably soon. Probably next week. خميس الجاي مناسب.